A very good day to Doctor. Throughout this video, I will present our PBL tool which titled Calibration and Sensitivity Measurement of a Light-Dependent Resistor, which is called LDR. And our team members are Jessica Ang Ching Yong, Lee Ching Yao, and I'm Uyong Eun. The objective of this project are, firstly, to calibrate the LDR by establishing the relationship between its resistance and the intensity of incident light. Second, to measure the sensitivity of the LDR by determining how much the resistance changes when the light intensity changes. An LDR is a sensor whose resistance varies according to the amount of light it receives. As the light intensity increases, its resistance decreases. For the setup overview, in the experiment setup, the LDR sensor module was connected to an Arduino Uno. The Arduino provided a 5-volt power supply to the sensor, and the analog output pin A0 was used to acquire the signal while the ground pin was connected to the Arduino ground. This setup allowed us to measure and calibrate the light intensity detected by the LDR. During the experiment, a light source was positioned at a fixed distance from the LDR sensor. A smartphone lux meter application was used to measure the light intensity in lux. To measure accuracy and consistency, control lighting conditions were maintained throughout the experiment. For data collection, the Arduino continuously read the analog values from the LDR sensor. These analog readings were converted into voltage values and displayed through the serial monitor in real time. Measurements were taken at 10 different light intensity levels to observe the sensor's response. As for data communication, LabVIEW software was used, a blank virtual instrument which we call VI was created, and serial communication blocks were added to the block diagram. The Arduino COM port was selected, allowing LabVIEW to receive and display real-time sensor readings from the Arduino. From the experimental data, we observe a clear inverse relationship between light intensity and LDR resistance. When the light intensity increased from low lux values to a higher lux values, the resistance of the LDR decreased significantly. This result validates the operating principle of an LDR, where higher illumination leads to lower resistance. The LabVIEW interface also successfully displayed the real-time voltage readings received from the Arduino. Talk about the real-life application. One practical application of the LDR is in a safety door system. A light beam is directed across a doorway into the LDR sensor. When the path is clear, the beam continuously shines on the LDR, keeping its resistance low. However, when a person passes through the doorway, the beam is interrupted. The LDR detects these changes, causes its resistance to increase rapidly, which can then trigger the door control system. In conclusion, we successfully calibrated the LDR and established the inverse relationship between light intensity and resistance. We also successfully integrated Arduino with LabVIEW, enabling real-time data acquisition and monitoring. This project helped us understand sensor calibration, sensitivity measurement, and practical data communication techniques used in engineering applications. That's all from us. Thank you.